Today we're going to be talking about stretching or compressing functions, linear functions, excuse me. So, let's get started. We got 4 of them to get through. Let g of x be the indicated transformation of f of x. Write the rule for g of x. Original function, f of x is equal to 3x minus 2. We're going to horizontally stretch that by a factor of 2. So, when we have a horizontal stretch or horizontal compression, either or, it's the x-coordinates of the function that are going to be changing. And if you think about it, a horizontal stretch, so we're going to be, pulling away from the y-axis, a horizontal stretch, the slope of this line, it's going to be getting flatter. So think of it like, it's going to be leveling out. A horizontal stretch or compression, either one of them again, it's going to cause us, or it will have us divide x by the factor that we are stretching or compressing it by. And so here I show that by having f of x over b, and b is going to be our factor. So f of x changes to f of 1/2 x because we're dividing by a factor of 2, 1 over 2, x. And so we can, g of x is going to be equal to f of 1/2 x. And then I can plug in, this is going to be my 1/2 x, and I can plug 1/2 x into this original equation up here. And I'm going to have 3 times 1/2 x minus 2. And I'm going to simplify this to get my new equation, g of x, 3 over 2x minus 2. And now I'm going to graph this just so you guys can get a visual of what is happening. The blue one here, that's my g of x, that's 3 over 2x minus 2. And the red one is my original. And like I said, when we do a horizontal stretch, our slope is becoming flatter. It's leveling out. So that's what it did. The slope actually came closer to the y-axis. Our next one that we'll do, we'll have a horizontal compression. So f of x is equal to 3x minus 2, and we're going to horizontally compress that by a factor of 1/2. Again, a horizontal stretch or compression will change the x-coordinates of a function. And of the horizontal compression, our slope will become steeper. So think that a horizontal compression, a compression, we're pushing it closer. We're pushing it closer to the y-axis, and our slope is going to become steeper because we're pushing in on it. We're pushing in down here. So our slope will become steeper, and with a horizontal stretch or compression, we're going to divide x by the factor. And so, again, we have f times 1 over bx. And do you notice that our factor is 1/2? So it's going to change to a 2. Now, and why does it change to a 2? Because you can read it as 1 over 1/2. When we have 1 over b, we're doing 1 over 1/2, which that doesn't make sense. And if you recall, when you divide by a fraction, you multiply by the reciprocal of the fraction in the denominator position. So this changes to 1 times 2 over 1, which gives us 2. So we're going to horizontally compress by a factor of 1/2, which we take our x-coordinates by 2. So I'm going to plug that into my function here, and I get 3 times 2x minus 2. And I simplify to get g of x is equal to 6x minus 2. And so this is our new rule. And once again, I'm going to graph this right away just to give you guys a visual of what's going on. And the blue one here, that's our new one. That's g of x, and that's 6x minus 2. And our original, we have f of x equal to 3x minus 2. Our y-intercept is the same on both of these. But you can see that our slope did get steeper because we pushed in. Did you see that it got closer to the y-axis? Pushed in on the bottom because we got closer to the y-axis. So let's talk about vertical stretches and compressions. So those are our horizontal ones. Let's talk about some vertical ones. So with a vertical stretch or compression, we're going to change the y-coordinates of a function. And so let's think about a vertical stretch. Vertically, we're going to stretch it out. So we're stretching it away. We're going away from the x-axis. And what's going to happen to our slope? It's going to become steeper because we're pulling it away. So it's going to be, when we're going up, it's going to become a little bit closer to the y-axis there. So with a vertical stretch or compression, we're going to multiply the whole equation by the factor. Since we're changing the y-coordinate, the whole equation is going to be multiplied by our factor. What does that look like? Our original equation, f of x, is going to change to the factor a times f of x. So with our first one, f of x is going to change to 2, our factor, times f of x. And then we can go g of x is equal to 2 times f of x. And I'm going to plug in our equation for f of x, so 2 times the entire thing. We distribute our 2 times 3, and 2 times negative 2. And simplify, we get 6x minus 4. That's very similar to our last one, but our y-intercept changed. So, as you notice, on the vertical ones, our y-intercept changed. And the blue one is our new one, 6x minus 4. And the red one is our original, 3x minus 2. And our slope did get steeper because we pulled this up. We pulled this down. Our slope got steeper. And our last one is vertically compressed by a factor of 1/2. So again, vertical stretch or compression will change the y-coordinates of a function. Y-coordinates. What happens when we change the y-coordinates? We multiply by the whole equation. So a vertical compression, what's going to happen to the slope? Vertically compressing, so we're pushing down, we're pushing towards the x-axis, and it's going to cause this to become flatter. It's going to make it level out because we're pushing down on here, we're pushing up on here. Our slope will become flatter, and I just said this a second ago. Vertical stretch or compression, we're going to multiply the whole equation by the factor. So again, f of x changes to a, the factor, times f of x. Let's get on to it. F of x changes to 1/2 times f of x. And then, so we can make this equal to g of x. And then plug in our equation. And then I'm going to distribute my 1/2. So 1/2 times 3 would be 3 over 2x. And 1/2 times a negative 2 gives us a negative 1. And this is our rule for g of x. It's our new equation. And I'm going to I did graph that one as well. And the blue one, once again, is our g of x. And the red one is our original, 3x minus 2. And the slope did get flatter, as you see, because we pushed down. It was a vertical compression, so we pushed down on here, pushed up on here, and it became closer to the x-axis. Make sure that you put both of those formulas or recipes into the notes at the beginning of your handout. So that should be all filled out now.